The question says figure 7.17 shows a series LCR circuit connected to a variable frequency 230 volt source where inductance is 5 Henry, capacitance is 80 microfarad and resistance is 40 ohm. We have to determine the source frequency which drives the circuit in resonance, obtain the impedance of the circuit and the amplitude of the current at the resonant frequency, and determine the RMS potential drop across the three elements in the circuit. Show that the potential drop across the LC combination is 0 at the resonant frequency. Now we know the driving condition for resonance is the frequency of the source matches the frequency of the circuit. So that is the main condition of resonance. And at resonance, the inductive reactance is equals to capacitive reactance, and upon rearrangement for omega, there is the angular frequency, we will get the value of omega is equals to 1 by under root the inductance multiplied by capacitance. And at resonance, the impedance is equals to R, because we know the formula for impedance is under root R square plus capacitive reactance minus inductive reactance whole squared. Now when at resonance XC equals XL, this quantity becomes 0, so Z is equals to R. So at resonance, the impedance is equals to R, or Z equals to R. Now current at resonance is given by voltage divided by the impedance or the resistance, and the peak current similarly is defined by the peak voltage divided by the resistance. And potential drop at resonance is given by VR is equals to Im multiplied by R, where Im is the peak current and R is the resistance. Similarly, VL, that is the potential difference, potential drop across the inductor, is equals to Im multiplied by XL, where XL is the inductive reactance. Similarly, the potential drop across the capacitor is equals to Im multiplied by XC, where XC is the capacitive reactance. So we have to calculate the resonant frequency, we have to calculate the impedance of the circuit and the amplitude of current at the resonance frequency, that is Im we have to find out in the second question. We have to find out omega in the first question, and we have to find out potential drop across these three components, that is the resistance and capacitor and the inductor. So omega naught or the resonant frequency is given by 1 by under root LC. Upon substitution, we will get to know that it is equals to 50 radians per second. And as discussed earlier, at resonance, impedance is equals to resistance, and that will be equal to 40 ohm, because we have been given that the value of resistor, the resistance of resistor is equals to 40 ohm. So Z will be equal to 40, and the peak current is given by peak voltage divided by R. Now unless specified, the given potential difference is always the RMS. So for calculating the peak voltage, we will multiply it with root 2. So root 2 multiplied by 230 will be the Vm, or the peak voltage, divided by resistance, that is 40, will give us 8.13 ampere. That is Im, the peak current would be 8.13 ampere. So we have solved this question A and B. Now we have to determine the RMS potential drop across the three elements of the circuit. So we have to find out IRMS for that. So IRMS is equals to peak current divided by root 2, and this will give us 5.75 ampere. So potential drop across the resistor would be equal to IRMS multiplied by R. That will give us 230 volt, because R is 40 and 40 multiplied by 5.75 will give us 230 volt. And VL, that is the potential drop across the inductor, is equals to IRMS multiplied by inductive reactance. This will give us 1437.5 volt. Similarly, the potential drop across the capacitor would be given as IRMS multiplied by capacitive reactance. This will give us 1.37.5 volt again. We have calculated XC as 1 by omega times the capacitance, that is 80 microfarad. 80 microfarad, yes. Now we see that VL is equals to VC. Potential drop across the inductor and the capacitor is equals to 0. Thank you.